Hello again. Let's suppose that we've now been tasked with this problem. We are to consider f of x equals 1 minus 1/3 x. We are to graph f of x. We are to define g of x by f of negative x, and then graph that and interpret geometrically. And we are to define h of x as negative f of x and graph this and interpret geometrically. This looks like quite an arduous task, but let us proceed. Okay, so f of x is 1 minus 1/3 x. Well, we're used to lines being in the form y equals mx plus b, slope-intercept form. And this is, although it's a little tricky, it's in reverse order from what we might expect. So remember, m, the slope, is always the coefficient of x, and b is the other thing. So usually we would write this as negative 1/3 x plus 1. Okay, so the slope is negative 1/3. The y-intercept is plus 1. So if we were to graph this, well, the y-intercept is plus 1, so we know one point in the line is 0, 1. The slope is negative 1/3. That might seem a little tricky at first. This means every time we go right 1 in x, we decrease our y value by 1/3. So we would have the point of 1, 2/3 on the graph. If we went right by 1 again, we'd have the point 2, 1/3 on the graph. But I don't like dealing with fractions, and I'm sure you don't either. So to make this a little easier on us, we're going to think up another integer point, meaning a point with integer values, which is also on this graph. And after some careful consideration, we might come to the idea of substituting x equals 3. So if I plug 3 in for x, I get f of 3 is negative 1/3 times 3 plus 1. Okay. So 1/3 times 3, well, that basically cancels, and this becomes negative 1 plus 1, aka 0. So this means the point 3, 0 is on our graph, because f of the x value is always the y value. All right, so these 2 points are on our graph, and we know that the graph is a line because it is essentially an mx plus b form. 2 points that terminate a line, so we can connect the dots here. And then this. Oops. All right, pretend that passes through this point. Whatever. You get the idea. That's the graph of f of x. Okay, on to part B. So g of x is supposed to be f of minus x. Let's do that down here. So f of minus x means that we substitute negative x in place of the x. So this is the same as, I'm going to use this form here. This is negative 1/3 times negative x now in parentheses. So we're doing f of minus x plus 1. Okay, so a negative times a negative is a positive. So this is equivalent to positive 1/3 x plus 1. Okay, so this is a line. The slope is now positive 1/3. The y-intercept is still positive 1. All right, let's try to graph this. So we know the y-intercept is positive 1. So 1 point on the graph is our favorite point, 0, 1 over there. We'll find another integer point. Instead of plugging in f of x equals, x equals 3 to the equation, I'm going to plug in x equals negative 3. Although it works if you plug in 3 too. Okay, so g of negative 3 is 1/3 times negative 3 plus 1. So what's 1/3 times negative 3? Well, if you answered negative 1, good for you. You got it correct. So this is negative 1 plus 1, aka 0. So what point is on the graph? Well, we plugged in negative 3 and we get 0. That means the point negative 3, 0 is on the graph. 1, 2, 3, negative 3, up 0 is this point. So we know this point is on the graph of g of x, and so is this point. Now we can connect the dots. And this must be the graph of g of x. Okay, but we only answered half the question because we're supposed to interpret this geometrically. And how can I interpret this geometrically by comparing f of x to g of x? Well, I might observe the y-axis seems to slice them right in two. In fact, g of x is the mirror image of f of x under a reflection over the y-axis. So such a reflection will leave the y-intercept unchanged, and then every other point is going to move to its reflection over the y-axis. So this point moves to that one, etc. Okay, so our answer is that answer to the question of interpreting this geometrically is that this is a reflection over the y-axis. And in fact, anytime we take a function and we replace x by negative x in parentheses, that will always be a reflection over the y-axis. All right, on to the third and final part. Okay, I erased the board to give us a little bit more room to work. So we are to graph h of x, which will be negative of this function f of x. We're also going to interpret this geometrically. So h of x is the negative of the whole quantity f of x. So we're going to put it in parentheses. And f of x we saw, you could rewrite it as negative 1/3 x plus 1. So now we're going to distribute this negative out front. Remember, this is equivalent to negative 1 times this quantity. So negative times a negative is positive 1/3 x. Negative times a positive is negative 1. So this is the equation of h of x. Okay, so again, this is in slope-intercept form. So mx plus b, or slope m is 1/3, our y-intercept b is negative 1. All right. Y-intercept is negative 1. Let's graph that. 0, negative 1. So this point is on the graph of h of x. And if we wanted an integer point, I could plug in negative 3 for x, and I would get h of negative 3 is 1/3 of negative 3. Whoops. Actually, I lied. Let me plug in positive 3. You could do this too, but I think it'll be clearer with positive 3. So h of positive 3 will be 1/3 of positive 3 minus 1. So 1/3 of positive 3 is 1, minus 1 is 0. So if h of 3 is 0, that means the point 3, 0 is on the graph of h. 1, 2, 3. Okay, it's this point again. Now we connect the dots. And I get this function h of x. Okay, we're not done though. We still have to interpret this geometrically. Now, one way to interpret this is that this is the translate of g of x down by 2. Although that's correct, that's not really what we're looking for here. We want to know how h of x relates to the original function, the parent function, f of x. So imagine that we just ignore g of x entirely, and we only look at f of x and h of x. Well, then we see that much like how g of x was a reflection over the y-axis, h of x is a reflection of f of x over the x-axis. Right? So such a reflection preserves any x-intercept, and it maps any point on the graph of f of x to its reflection over the x-axis. Okay? So the x-axis is an axis of symmetry of these two functions. All right, so that is a reflection of f of x over the x-axis. In fact, if we had any other function and we did the same operation to it of negating the entire function, that would also be a reflection over the x-axis. Thanks for watching.